Okay, so for problem 11 in section 16.5, I'm supposed to integrate the function f of x, y, and z is 1 over x squared plus y squared plus z squared, all to the 1/2 power, over the bottom half of this 5 sphere. Okay, so to accomplish this, first you need what? Okay, good. 3 squigglies. Good start. What else do you need? Okay, we need some bounds on the squigglies.
Substitute the values of x, y, and z.
What? For what?
Conversion factor.
Crazy. Not yet. You're getting ahead of us. So, right here, what should go?
Rho squared d rho d theta dt.
The hell are you talking about? Where'd you get that shit?
Well, it's a sphere, so I'm using spherical.
Yes! Good call. Okay.
Y sine d.
Isn't that the conversion factor?
You remember that? Not, oh, that, I guess that's where my problem is.
Alright, perfect.
Didn't have that.
So, it's good that you're jumping straight to spherical, right? So, we should move to spherical. There should be something here that I'm missing still.
Yeah.
And then this thing should be the dv, right? So I need a rho squared sine phi, and then a d that I need to fill in whatever order I pick. What's this middle thing?
It's given to you as 1 over root of all of that, but x squared plus y squared plus z squared is rho squared. So 1 over rho.
Okay, and really, so keep in mind, I should be worried if I took some nonsense squared and then square rooted it, right? So really I should maybe worry about absolute value here, right? But as long as I keep rho positive, rho and the absolute value of rho are the same thing, so I can drop the absolute value letters. You guys see that? But I need to remember that. I have to be careful to keep my rho's positive when I set up my bounds.
How come that row isn't to the 1/2 power?
Because this junk here is 1 over rho squared square root.
Okay.
That's the thing I thought you were getting. Okay. All right, so then what else do I have here? Does the order matter much on this one?
As far as I know.
Maybe let's think about our region first. So, bottom half sphere, right?
Oh, so we need to make sure that our phi is from pi over 2 to pi.
Okay, so it sounds like the phis need to go, let's see, we don't want the top half, right? So we want to start when it crosses the x-axis, which is phi is,
Would it be negative pi 0, right? Or
I think you want pi over 2 to pi to keep everything positive.
yeah.
You guys with me on that? Okay, so I'm going to throw the phis in first, I guess. Oops, I said we want to start at pi over 2 and go to pi, right? For phis. Okay, now what?
Theta goes all the way around from 0 to 2 pi.
Theta goes around. Okay, so I'll put that one last because that one's easy. And now I'm left putting rows in the middle. Does that seem okay? Is that going to cause problems?
No, that's what I'm saying.
No, I mean, no matter what the theta and the phi are, right, the rows still go from 0 to 5.
And I was wondering about that too. It wouldn't be like negative 5 to 0, right? Because it's the bottom half, or it doesn't matter?
It doesn't matter, except we did this thing where we swapped the absolute value of rho for rho, right? We could just as easily set this thing up as,
Top half.
yeah, so if you're going to do negative 5 to 0 for the rows, your 0 to 2 pi and your thetas won't make any difference, right? But now, negative 5 to 0 means that my fees have to live, yeah, they have to live on the top so that my negative radius gets down there. You guys see that? So you could set that up from 0 to pi over 2 for the fees. You guys with me on this? But now you've got this 0 to negative 5 BS going on. So your rows are all negatives. The absolute value of rho isn't rho, it's minus rho. So you'd have to do 1 over minus rho. And then whatever. And all this serves to do is be confusing. You guys cool with that?
So
You will get the same answer out of it, but it will be more confusing. Cool?
Yep.
At least assuming we set it up right. If we didn't set it up right, what will we be off by? Probably a minus sign, right? Okay, so let's just assume that that would give us the same answer. And we won't check it because it might not. It will, but we won't check it. Don't check it. Okay, so how do you actually accomplish this integral?
What was the rule that we could split them up so that the fees are with each other, the rows are with each other, and the thetas are with each other?
I mean, 1 over
Like,
rho is just
simplify
constant with respect
First
to
to get your rows
the
together.
Sure.
That's-
So the order doesn't matter, right? Because this is all a bunch of stuff multiplied together.
Yeah.
So you could break this thing up into what?
You just need fee, right? One cancels, so
Yeah.
it'd be,
Yeah,
zero
so we-
to 5 would be-
So I'd be thinking this is 1 times rho times sine of phi, right?
Yep.
Function of theta, function of rho, function of phi.
Yep.
You guys all with me on that? So I'm going to break this into the integral from 0 to 2 pi of 1 d
Theta.
theta times the integral from 0 to 5 of
DP.
rho d rho.
Rho.
Oops, that's not a rho, that's a p. That's a rho.
How do you tell the difference?
P's go like that, and rho's go like this.
So just tilt it.
But that's my handwriting, not necessary. Yeah, this little r that we use in cursive, right?
Yeah.
When you make one actually in cursive, it looks like this,
Okay.
which looks a little bit like this thing.
Well,
If you take that tail and put it over here,
I'll take one before.
whatever.
Yeah.
Shut up. Make it a p. Who cares?
Okay.
Okay, times what?
I over 2 to pi of sine phi d phi.
Good. Cool. And so out of the bits here, I feel like I get a 2 pi, a 25 halves, yeah. And a, see, sine looks like this one. So from pi over 2 to pi is this stuff,
Yeah, I think it's just a 1.
which is 1.
And that gives you the 25 pi.
So I got 25 pi. Okay, now what's the meaning of that?
That is the area on the
No.
sine.
I think the volume.
Volume
of that
sign.
half.
That's the temperature
No.
over that sphere.
Yeah.
Oh, right, because it's a function of all 3 variables.
This guy? That's, or something. I would think that's, if this is the density, then this is the total mass. You're integrating some function, right? Over a 3-dimensional volume.
total energy.
You guys see that? So your units on this thing are going to be F units, right? Like whatever F's output units are, times X units, times Y units, times z units. And normally the way this makes sense to me is x, y, and z are all some kind of distance, right? So like this object here is like a volume. If this object here is a something per volume, then the volumes cancel, right? And this is the total amount of something, as long as this guy, f, was a density function. So like if that's the concentration of poison gas per cubic meter, right? Then this is the total amount of poison gas in the room. Or this is the total weight of this sphere, right? If this is my density function, where it's 1 over rho, tells you how heavy this stuff is. You guys cool with that? That kind of make sense? Stuff that looks like 1 over rho's, that's inverse linear. That's not so common in the world. Inverse square is really common. That's stuff like gravity or friction in a pipe or something. So one thing this could be, right, is like total energy loss to friction or something, which you would get with a 1 over rho squared if you were doing the appropriate thing. Cool? Got it? Okay.
So when you integrate the 3, is it usually going to have that type of units?
Yeah, when you have a triple integral, right, you're adding up over the x's, the y's, and the z's. So you're getting some kind of volume times whatever the units on this guy are. If this guy's just a 1, right, then you're getting a volume. But if this guy has units, then you get those units times volume units. So oftentimes those are density things so that the volumes cancel and you get something kind of sensical. Cool?